Oops. Oh shit, what did I do there? Oh, backspace to go to the start of the track. Okay. Instead of enter and then backspace. So, good evening, heroes and heroines, and welcome to Practising Programming in C, in which I first of all pick some music to listen to before we continue with our explorations in our innovative... I need some buzzwords. Our innovative attempt at abstractly telling a computer... Computer isn't a fancy enough word, it's too common. How to convert a human-written configuration file into a a struct. Yeah, anyway. I think I'd like to do, yeah, this could be a nice amount of time to do. Do a couple of hours, and then a couple of hours, then do a short break for food, and then come back and do another session. I think that's what I'd like to try and do, rather than doing like a great big long, like 4-hour session in one go. I'd rather kind of like try and get some food in me at some point. So yeah, we are going. How long have we been recording for? A couple of minutes already. A couple of minutes to select our music. So yesterday we started our parser. We actually fixed some stuff in the tokenizer, and then we started on our parser. Well, first of all, parsing this support struct here. I mean, struct is, I guess, compound type really is what this kind of is. Now, one tiny thing that we can do to make this a little bit better already. See this icon thing here? This parse single string assignment is it's not specific to the icon. It takes a config identifier. This I is going to be saying that we are talking about the icon. Because if you look at the config identifier, these are they, and one of them is ident icon, and that refers to this little fucker here. So basically, you can use that to you can use this to get to produce this thing. So what we could do is we could say error field already set. And then just yeah, let's stick the new line on there as well. Might as well. It's going to be the identify strings, isn't it? Field already set that. Let's write it like that. And also for the invalid identifier. Oops. Invalid identifier. Let's make that there. So error field already set. Icon. Error invalid identifier something. Yeah. So that seems better. Now another thing I was wondering, I think Interfaraz in fact was actually talking about this very thing yesterday, was making a function that essentially does the token equals itself. Right. Now maybe, well, maybe we sort of still need this sort of an idea, right? Well, something I'm wondering about doing is making this sort of compound type setting procedure. Just sort of make this thing a generic thing that handles all the different types of stuff, basically all the different types of assignments. And we already kind of have this idea in here, right? We should be able to handle single types as well as compound types. Like automatically we should already be able to, well, I say automatically, I mean, because this thing here, we're checking if it's a semicolon, and if it's a semicolon, we understand us to have finished the assignments, essentially. So we might be able to make just a fully generic thing here. That essentially it takes like basically like a type spec, for want of a better word, or an identifier description, and that basically says what the identifier's ID is. So in this case, it would be it'd be support in this case. So in the same way, like up here, right? When we call support, we've done this procedure here. We said if token is equal to ident support, right? So we've figured out that this token is this. So if we see that, we want to go we want to first of all skip past that actual token, and then you want to call this set support function. So we've already got the idea of that being a support. This type spec sort of a thing. I'm thinking we could say that a type has this type here would have the ID of support, and it would have a number of fields. The fields would be icon and URL, right? And the type spec could also say how many of them they can have, whether they can only include 1 or 2, right? And maybe also if the type itself is also a compound type. So in our case here, the icon is not a compound type. The URL isn't a compound type. However, when you come down here, when you got a project can itself include projects, right? So a field in a project could validly be, a project itself could validly contain a project which itself is a compound type. So then you'd need to then be able to parse this whole thing as well. So basically recurse, essentially. So I'm thinking I might try and do that. And we also need the idea of actually scoping at all, really. So like, for example, I mean, we're not really pushing anything on to anything here at the moment. We've just got a whole unstructured list of tokens, which we're in the process of parsing into some sort of structure. When we are in this project, say that we're in this project scope down here, we don't want to be able to say, like if we say, for example, icon is equal to something, we don't want that to be, we don't want it to be using this icon or overwriting this icon, right? It shouldn't be able to access this, but it should be able to access this support. And we could actually do that ourselves. We could say, well, actually the project itself couldn't include the support. Only people can include support, right? And that's what you see in here. So you see the person Mio, includes support, right? So basically this support page should be accessible. Well, should be, how can I say this? This support page up here should be accessible in this file here. And similarly, this support support PayPal here, this should be accessible in here. But if there was a URL set for that guy, we should be able to overwrite it. I'm not sure if that makes any sense at all. But the whole thrust of that was essentially, it's basically the idea of making sure that scopes can only access the stuff that they should be able to access. So yeah, maybe what I'll do first though is parse another compound type, so then we can see more of what we have to work with. So we've done support, so this is invalid, and this is invalid. In fact, I might leave a note actually just to say I'll do that for there as well. Ah, yeah, right. That's another thing I need to do. I need to actually ignore comments. So, in the expect, that's a good point. In the expect token, we really want this to be skipping comments, right? So it's like, T token at the key current index type is equal to a token we want to do that. So we're still getting an invalid identifier. So it's seeing that as an identifier still. Well, T current index is less than the T current, and the T token type is a token comment. Skip past it. I mean, I should actually say skip comments, because that's probably going to happen a few times. It's better token identifier. Invalid identifier, something, so to token identifier. So where we're doing expect token at the moment, parse single string assignment. I think we've got an is token, haven't we, also, unfortunately. I mean, in some ways, if we're going to be skipping the comments, it sort of suggests that you don't want to even add them to the token list in the first place, doesn't it? Because we're not doing anything with them. I will keep this function here. Considering the necessity of this function. So here we go. And then if the token type is not equal to a token comment, so yeah, we don't get that issue now. I might just make a note in here as well. You know, tokenize. I mean, in some ways, we're sort of wasting. Well, I suppose you do have to skip past it, don't you? Token type, token comment, yeah. I mean, maybe that's fine. You just do that. But yeah, like I say, I will leave a note. Yeah, that'll do for now, I think. So we were down at expect tokens. The field already set. What were doing? We were doing the set thing, weren't we? Set support. Oh right, yeah. So I just added that. So that needs to fix it. Then I did it. Yes. So what I was going to do was parse another compound type. So let's do the include. We'll do it in the same way as the set support. And this should take a config include. And also, I mean, I was sort of thinking that this isn't the right thing to be doing actually. I shouldn't be parsing directly into the actual finalized struct at the moment, because we still don't know what the actual final value is going to be. I think we still need some sort of intermediate representation, which we then go through and resolve all the stuff and then put them into the struct that they actually need to be in. But I'll just keep going like this for now. And there should be a few of them. Right, so here we've got a case we need to push on some of these dudes, which is different from what we've had before. Just double check that the config support actually contains its ID. It does contain an ID. So all that means is it's just basically the support ID. Similarly, include ID. I mean, you could sort of say, you could call it the file, actually. And I might do that. File name. So we're going to have a file name, we're going to have a number of allows, which means we're going to have to push on a field onto this thing. Yeah. Let's forget about the allow for now. Let's just push on the ID, file name rather. So the dest that should be this. If token semicolon, then we return true. I think that should be a valid thing to do. Token assign, token string, yep. If it's an open brace, then we're going to go in here. And if token equals allow, do nothing, basically, for the moment. Well, actually you need to skip past it, don't you? This escape string assignment, by the way, I think I'm going to rename that to depart. Right, so if that, we're just going to do an if 0. Should be able to return false, it seems. Because it'd be a syntax error. Yeah, which is fine. Okay. We're also going to have a deny, but we're not going to actually have that. Well, we're not using it, rather. We're not using that at the moment. And we might not actually do it. I mean, it sort of seems like we might want it because symmetry, I guess. Allow and deny. But then, I mean, the idea is basically allow is just, you know, this is a restrictive thing. So it's like you only allow person, medium, and product default medium things to be set in the config included, you know, in the includes. But if it's deny, then it's like, well, every single thing, every single field can be set apart from the ones that you don't, that you explicitly disallow. So yeah, just if 0 this for now, and do the same thing, depart the string assignment. That ain't being used, yeah. I mean, in some ways, I could like just make a define for that. But anyway. So yeah, I think we're establishing the syntax there and handling all that stuff. So when we do the parse config down here, we're going to have an else. And then we're doing the same business here. And we don't actually have this function yet, unfortunately. Yeah, I mean, it's going to be the same as this dude here. Oops. Sorry. Allow, isn't it? And also, this thing is going to have a number of them. Oh yeah, we need so yeah, if we're going to have a number, we need an actual count of them. And it's like, for the allow count, we're going to be printing the I. Pretty sure that's all it is. Because we've actually set them, you know, it's a for loop, so it's like we know that information, so we shouldn't need to have to check your string empty. So for each allow is going to do that. We could do also the deny as well, but we don't have it at the moment. Don't finally do that. So allow, deny, that. Print include. Yep. Okay, so then let's just add to the thing. Okay, so that's, yeah. Oh, that's interesting. So we've now got a situation where we've got this one up here, and we've got this included here. I mean, I guess we could sort of say, for this one up here, we could just increment the thing. I mean, obviously I'm going to have to push this stuff on, but like, you know, just increment the allow count. What do we have? It's going to be the dest allow count. And this is going to be, and then when we do the print, we're going to have to actually make sure we don't actually try and print the stuff out. Basically, for now, we just have to do this. Print string C, yellow bold. And then we want to print out the number of allow directives and the number of deny directives. Another interesting thing here, actually, is this interesting, actually. We've got a situation here where this thing, well, yeah, we're gonna, this whole thing here is going to be our string, isn't it? So that's going to get pushed on, and then it will be there. So it is a normal assignment. It's just an assignment that happens to have have scoping in it itself. So yeah. Let's just quickly print out the number of allows and the number of denies. Right, cool. Yeah, so that was just so we can distinguish between these two guys here. This include up here, and this include down here. And like I was saying earlier, in terms of the scoping, cascading down, and also making sure that stuff can only access the scopes that we're talking about. When you do an assignment like this, you actually are referring to, well, I mean, this actual thing should be cascading down. So we need a way I guess we need a way for this project. Like all the siblings kind of need to be sort of listed together. Yeah, it's unfortunate actually. It's unfortunate that this guy isn't exactly the same as the support, because we can actually have multiple things of these, so they don't actually match. If you can only have one of them, then you know that the struct itself is going to contain space for one of them. If it can contain multiple, then the struct is going to contain a pointer to the first one of it. So you need to be pushing onto that. And if we send it a type spec, if we send these set functions a sort of a type spec, then they will be communicating what the thing is. They'll be communicating whether there can be multiple of the same field, or only one of the same field. Which these guys then use to sort of say, well, if you can have multiple, then you push on to that thing. If you can only have one, then you set it directly. Like, well, I mean, it's essentially parse single string assignment, isn't it? I mean, I wonder if it would be parse single string assignment, you'd be responsible for saying push or set. Do you know what I mean? Like this dest here. Well, actually, because this is a string, isn't it? You want to be pushing on. It's not just the string, it's the token itself, isn't it? So if token equals icon, yeah, I see. So this dest icon, there's only one of them. So I think it would be out here. It'd be like if token was, if you see the thing, if you see an allow, for example, I mean, you're basically actually looping through the type spec, saying if. I mean, actually, you could say this, couldn't you? Rather than using icon, you can say. And also, you can just do this, can't you? And then, rather than using the actual string, because it's not the string, it's just the token identifier. So it's like the token. Just see where that is. Like the token. Oh, it's not a token, is it? It is a. Sorry, it's an ident icon, right? Yeah. So token equals. What are these guys? Config identifier, right? And then, whereas previously we were using the string, were we not? So it's basically right. Well, actually, what was I saying? It was this. Oh no, it's ident allow. Incompatible argument for type 2. Yeah, right. I mean, that was another way of doing it, wasn't it, actually? Yes, that still works. So the token is an ident include. It's getting a bit lengthy, that line there. Might just break this down. And that. Just do that. Still haven't really got a good story together as to where you do this, how you break this, whether you do it like that, or whether you do it like that. Don't know. I think that should be a reasonable way of doing it as well, actually. Because a token... I think we're only testing our stock identifiers. So I'll tell you what, I'm going to roll this back, actually, and I'm going to use this idea here. So the token equals is still going to, it's going to test against strings like before. Right. And then you just sort of say, you say that instead. Might just give me a bit more room to maneuver. You know, if you need to figure out the equality of tokens that aren't actually identifiers. So the thing that motivated that change was essentially the idea of that type spec. So if we're passing in a type spec in here, we want to be, a type spec is going to include basically that kind of idea. Let me just do that. I mean, also a type actually is just an identifier, isn't it? So it's like, so yeah, what is support exactly? Identifier, yeah, right. So it's just all these guys. So it's a config identifier. Yeah, that's all it is, isn't it? So that's the ID. And then it is, so it's going to have an ID. And then it's going to have like a field, I guess. Right. And the field is going to have, itself is going to have, and then it's like whether it's, singularity field, field soloness. It's because I want to be saying, well, stop that. Singleton. Let's just use the word singleton. So if a field is a singleton, then we want to be setting it directly. If it's not a singleton, then we want to be pushing it. Probably just take it like that, maybe. Don't know. I mean, you don't have to change it, so I don't know. But essentially, the idea is if config types, so yeah, if there's no fields, you should be expecting there to be a semicolon. Otherwise, there could be an open brace. You know, you could be setting some more stuff. Tell you what, because the include is the more kind of complex case, slightly more complex because you can push multiple of the same guy on. Let's actually spec this out with the support for thing first. So the idea here would be you'd be looping through the spec. Oh, hold on, was I looking at set support anyway? Hang on. Set include. Yeah, I think I was looking at set support anyway. Jesus. So yeah, it takes the spec, and then in here, while it's not a closing brace, you want to be looping over the specs field count. Seeing what the ID is, and whether it's a singleton. If it's a singleton, you pass the single string assignment like this. I guess the question would be where we actually get this from. What is dest? I mean, dest icon is just a string, isn't it? So it doesn't necessarily have to be anything special. Although we will need to know where to actually put it. Before we do anything, let's just do the build type spec, right? It's going to be basically init type spec. So let's say we want to Oh, actually, we're gonna want a bunch of them, aren't we? Right. So we're to push a type spec, which is going to be saying it is the ident support. And the ident support is going to have... How can I communicate this exactly? I mean, I guess we need config fields. Bit cheesy, but it's like config fields equal the and the singleton is equal to true, and then you this is probably going to have to be varargs actually. Well, that's actually, rather than doing it like this, push a type spec and then push type spec. So we're saying we'll push it onto here. Right. Then you don't need that. Could that work? So you can only have a type spec. Like, one type can only have one type spec, essentially. Oh, where do we push it onto? I guess this could return a pointer to the actual thing, and then you can pass the pointer down here. FM. Right. I think that should be okay. Just build. Of course it doesn't. Why does it not build? Unknown type name field. Identifier. I just so want to spell identifier like that, don't I? So push type spec. Oh, right. Push type spec wants to return a pointer to a config. Set support wants to set the config type spec. Yeah. So parse config is going to have got the type spec. Does this take anything? It doesn't. So it does return that, and then this guy, what was it? Set support needed to take the type specs. Oh, right. It actually only takes the type spec for the include. For the support. Yeah, interesting. Maybe it should take, because you remember this set support thing is going to end up becoming just a generic function, right? So maybe they should be responsible for actually retrieving the spec from the specs. Before I do that, let me just see if I can I've got this capacity up here. I think I should be able to remove this idea of capacity. Let me just see if I can. It's basically, if this modded with the block size equals 0, I think that's what I need to be saying. Then I need to realloc by the count plus the block size. I think that's what I need to be able to do. So let me just see if this doesn't crash. It doesn't crash, so maybe that is right. Let me just double check. Oh, it's, I mean, it's sort of the token capacity now. And that's going to be token count plus, just to see if that did anything. So yeah, it does seem to be doing exactly what I wanted to do. So yeah, modding by block size. If the modded by block size equal to 0, then does that. So yeah, that's how you get rid of the capacity. Do 16 of these again. Well, actually, type specs. Yeah, we're going to have a few type specs, but I think for this type spec field, we can have a lower number because you don't need to allocate quite that much. So the first thing this guy needs to do is fit a type spec. Well, actually, as I was saying, you wanted to make sure that it is actually unique. Although, do I need to bother with that check? Because this is going to be purely internal. It's written by me, so as long as I've written it right, it'll just push on the right thing, and it won't push on duplicates. So long as I just actually write these guys not duplicated. No, let's not bother. Let's not bother to check it. So basically what we're saying here is we're going to first of all fit a type spec. And then we're going to say that the right. Right, I think that's right. Because that's the only thing we're passing here, isn't it? Push type spec, ident support, yeah. Fit type spec, success. The result pointer is going to be the address of this guy here. And because we're reallocating, I think I hope that these guys are going to actually stay in the same places. I might have to see if that is true. I mean, it hasn't been a problem before. You know, whenever I've done this sort of pushing stuff on and fitting it and all that business, reallocating, it has always worked. So yeah, we should be okay, I reckon. So here we go. I mean, actually, because it looks like 16, I really don't need to put. I mean, I know it's only. This is only going to exist for the. It's only going to last for the while this function is running, but whatever. I think this is exactly the same actually as this. Except it's going to be field. And it's got to be the size of a config. Well, I mean, we could actually call it this, couldn't we? Where's that? Where's my cursor? We don't need that. What do I call this? So, okay, it's just singleton. Push. Right. And I want to increment the field count. I think that's right. Then we will also want a free, well, free the entire type specs, honestly. Also, oh no, that does, yeah, it's different. Interesting. So we've got a read memory access push type field spec. Yeah, actually, just do it on all of these guys. So push it once, it's the second field. Trying to push onto the support. Copy type spec support. Oh, actually, no, it's when we add any of these, isn't it? Push type spec field. So it's taking a pointer to that. It wants to use the ID and whether it's a singleton. So we've got a pointer to the type. Config type specs allows a number of config type spec. So when we fit a type spec, we do this. So fit type spec. Count should be 0. Oh, we're not actually in it type spec. Yeah, so we are setting that to be nothing at the moment. Let's just do a little print type specs thing. Oh, sorry, didn't need to do that at all. Print type specs. Oh, you could just not set it. That's going to be happening down here as well. Oh, actually. Sorry. That's that. Identifier. Dude. Alright. So we are at least getting the support dude in. Oh, right. What's it saying? It's on the 0 page. For the field count. What is the field count exactly? So we initialize this here. We initialize it as empty, and then we push a type spec on. Push type spec. Oh, right. Of course. And reality doesn't clear it. Does it? The contour will be unchanged in the range from the start of the previous to the minimum of the odd new size. If the new size is larger than the old size, the added member will not be initialized. Yeah. If 4 inches null, then the colour is equivalent to malloc size. That might not be such a problem actually, but we do need to say. I do think we need to initialize results. Yeah, because I think what's happening is we're trying to push the types back onto here, but this guy actually initializes a new support. Which is kind of a bit cheesy. Isn't it? Well, actually no, because that's just it's a different thing, isn't it? We're not returning the types. We're not returning a new type specs. We're returning a new single type spec. pushing on a type spec. Oh. Well, hang on, we do this. But we need to set the count. Yeah, we need to actually initialize these guys. That's what we needed. Alright, so it's now working. So yeah, the only problem was that we pushed the types back. See, fitting a type spec only gives us some more space for it in the type specs at the end of the type specs. As Realx says, it doesn't initialize the guys. We set the ID to be that, which is what we passed in. Push that type spec, and then we need to initialize these guys. That was the only thing that didn't happen. So when we push a type spec field, we fit a type spec, and a field only has the values ID and singleton, so those are set fine. We don't need to initialize anything like that. Yeah, okay, so I get that. So we've got support. So how can I print this out a little bit nicer? Print type spec. Gonna give us a new line at the end. I think, is it just that? There we go. So the whole reason for doing this was to get set support to be using this type spec. So when we get in here, there's one type spec. We can get the types. We can get the one that we need first of all. I mean, actually, we can just have a function that does that. should it return a pointer to it? It could return a pointer to it, I guess, if it can't find it. And then down here, we're going to replace this information here. Actually, sorry, we want to keep that brace as a part of the while. So while we're not at the closing brace, we basically want to be saying if that thing is even in our spec. Type fields, type spec, was it? I don't think that comes back as a thing actually. And it's not even that, is it? It's the actual token. Right. Is that right? It's the content, isn't it? And unfortunately that's a string, isn't it? Yeah, that's unfortunate. Because you need to actually figure out whether that thing itself. Um, token equals config identifier strings. So we need to be saying if the t. So what is t exactly again? Tokens. A token. And a token is just it's just the content, right? I mean, also we need to check on the token type as well, actually. If the token type is the number, then we need to be passing the actual int64 there rather than content. So it's a string, so really so I've got this name here, this content name thing, which is going to be icon. So I need to search through the guys to see to determine what this actually is. Right, it's like get string, right. Well, hold on a second. The type spec is containing identifiers, so we can actually get the config identifier strings. So this ident icon, we can just compare it against that, can't we? Oh sorry, we're only getting we've only got the string. So yeah, what I'm driving at is you only need to test this string against the subset of strings in the type. Yeah. So to do fields is in spec. You do this, and you're passing this, the content, yep, which sounds fine. Passing the type spec, and then all you're doing is token equals, isn't it? Oh, mind you, token equals is taking the full thing. Well, actually, hold on a sec. That's taking a car string. Yeah. Yeah, so I can't do that. Tell you what, I'm just gonna go get some food. That was a couple of hours. The music's just stopped. So I'm gonna go get some food. And then return to this. So yeah, thank you very much, Hours and I'll see you shortly. Farewell for now.